There is a point in space where the influence of our sun ends. Not suddenly, not as a sharp edge, but as a gradual transition where the solar wind weakens and gives way to something much larger. This boundary is known as the heliopause. It marks the outer limit of the sun's influence, and beyond it lies the interstellar medium, the space between stars. For decades, this region existed only in theory. Scientists could model it, predict it, and describe it mathematically, but no spacecraft had ever reached it. That changed when Voyager 1 crossed the heliopause in 2012, followed by Voyager 2 in 2018. For the first time in human history, instruments were operating outside the solar system. And what they found was not emptiness. It was structure. A region that is not empty. The interstellar medium is often described as empty space, but this description is misleading. Even far beyond the sun, space is filled with plasma, a thin mixture of charged particles, mostly hydrogen and helium, spread across enormous distances. The density is extremely low, far less than anything we experience on Earth. But it is not zero. And that small amount of matter is enough to carry energy, interact with magnetic fields, and form measurable structures. When Voyager crossed the heliopause, it entered this medium directly, and immediately, the environment changed. The solar wind, which had dominated the spacecraft's journey for decades, dropped dramatically. In its place, Voyager began detecting particles that originated not from the sun, but from the galaxy itself. This was the first clear confirmation that the spacecraft had left the solar system, or the pressure beyond the sun. One of the most surprising discoveries Voyager made was the pressure of interstellar space. Scientists expected the region beyond the heliopause to be quieter, less dynamic. But measurements showed that the pressure in interstellar space was higher than predicted. Not because it is dense, it is not, but because it is influenced by multiple sources: magnetic fields, cosmic rays, thermal energy from surrounding regions of the galaxy. All of these contribute to a complex environment that pushes back against the solar wind. The heliopause itself is not a simple boundary. It is a region of balance, where outward pressure from the sun meets the pressure of the interstellar medium. And that balance is not fixed. It shifts over time. A sudden change in cosmic radiation. Another key discovery involved cosmic rays beyond Voyager approached the edge of the solar system. It detected increasing levels of high-energy particles coming from outside the sun's influence. Once it crossed the heliopause, those levels increased sharply. At the same time, particles originating from the sun dropped significantly. This transition provided clear evidence that the spacecraft had entered a different region of space. But more importantly, it revealed the role of the sun as a shield. The solar wind and magnetic field act as a barrier, reducing the number of high-energy cosmic rays that reach the inner solar system. Beyond that barrier, the galaxy becomes more present, more direct, and more measurable. The shape of the heliosphere. Before Voyager, scientists had only models of the heliosphere, the bubble-like region created by the solar wind. Some believed it was elongated, shaped like a comet's tail. Others suggested it might be more spherical. Voyager's data provided new insight. By comparing measurements from two different locations, scientists began to refine their understanding of the heliosphere's structure. It appears to be more complex than a simple shape. Influenced by the interstellar magnetic field, the motion of the sun through the galaxy, and variations in solar activity. This means the boundary of the solar system is not uniform. It changes depending on direction and conditions, and that has implications for how the solar system interacts with the galaxy around it. The sound of interstellar space Voyager also detected something unexpected. Not a sound in the traditional sense, but a pattern that could be translated into sound. Using its plasma wave instrument, the spacecraft measured oscillations in the density of interstellar plasma. These oscillations can be converted into frequencies that humans can hear. The result is often described as a hum or a background tone. This is not an artificial signal. It is a representation of real physical processes, a way of translating motion in plasma into sound, and it reveals something important. Interstellar space is not silent. It contains waves, energy, structure, a magnetic field from the galaxy. Another major discovery involves magnetic fields. Inside the solar system, the sun's magnetic field dominates. But beyond the heliopause, Voyager began detecting the magnetic field of interstellar space. Interestingly, the direction of this field was not completely different from the solar magnetic field. It was aligned in a way that scientists did not fully expect. This suggests that the interaction between the solar wind and the interstellar medium is more complex than previously thought. It is not a simple boundary between two separate regions. It is a transition where fields and particles interact continuously. A region still being mapped to Voyager is not mapping interstellar space in the traditional sense. It is not creating images. It is not scanning large areas. It is providing something more subtle, point-by-point measurements along its path. Each piece of data represents a tiny part of a much larger environment. But over time, these measurements build a picture of a region that was once completely unknown. And that picture is still incomplete, because Voyager is only one spacecraft, traveling in one direction, or through an immense and varied region of space. The limits of exploration. Voyager will not last forever. Its power supply is slowly declining. Instruments are being turned off one by one to conserve energy. Within the next decade, it is expected to fall silent. But even after it stops transmitting, it will continue moving, carrying with it a record of human exploration, and more importantly, leaving behind data that will continue to be studied for decades. Because what Voyager has already discovered is only the beginning, the realization. What Voyager found after leaving the solar system is not something dramatic in the traditional sense. It did not discover a new object. It did not encounter something unexpected in a way that defies physics. What it found is something more important. It found that interstellar space is real, structured, active, and measurable. It found that the boundary of the solar system is not a simple edge, but a region of interaction. And it showed that even the space between stars is not empty. What Voyager encountered beyond the heliopause is not empty space, but a medium. The interstellar medium is composed primarily of ionized gas, plasma, along with neutral atoms, dust, and magnetic fields that extend across vast regions of the galaxy. Its density is extremely low, often just a few particles per cubic centimeter. Yet it behaves as a physical environment, capable of carrying energy, sustaining waves, and interacting with radiation. For decades, this medium was studied indirectly through telescopes and models. But Voyager changed that. Plasma as a carrier of structure. Plasma is not just a collection of particles, and it is a dynamic system governed by electromagnetic forces. Unlike neutral gas, plasma responds strongly to magnetic fields. It can form currents, it can generate waves, it can organize into structures that persist over time. Voyager's instruments detected these properties directly. Through fluctuations in plasma density and electric fields, the spacecraft measured patterns that reveal how energy moves through interstellar space. These measurements show that the medium is not random, it is structured, and that structure reflects underlying physical processes at a galactic scale. Cosmic rays and the galactic environment. One of the clearest indicators that Voyager had left the solar system was the behavior of cosmic rays. These are high-energy particles originating from outside the solar system, being often produced by supernova explosions and other energetic events in the galaxy. Inside the heliosphere, the sun's magnetic field reduces the intensity of these particles. But beyond the heliopause, that shielding effect weakens. Voyager detected a sharp increase in cosmic ray intensity, confirming that it had entered a region where the influence of the galaxy is more direct. This discovery also highlights the role of the sun as a protective boundary, shaping the radiation environment within the solar system. The pressure balance at the edge. The heliopause is not a static boundary. It is a region where forces balance. The outward pressure of the solar wind meets the inward pressure of the interstellar medium. Voyager's measurements showed that this balance is more complex than expected. When interstellar pressure includes contributions from thermal energy, magnetic fields, and cosmic rays. Together, these factors create a dynamic environment that can shift over time. This means the boundary of the solar system is not fixed. It moves. It responds to changes in solar activity and the surrounding interstellar environment. Magnetic fields. Across the galaxy, magnetic fields are a fundamental component of the interstellar medium. They extend across enormous distances and influence the motion of charged particles. Voyager's data revealed that the interstellar magnetic field near the heliopause is not entirely separate from the solar magnetic field. Instead, there is a degree of alignment. This suggests that the interaction between the solar wind and the interstellar medium is continuous, rather than sharply divided. And it also indicates that magnetic fields play a key role in shaping the structure of the heliosphere itself. Understanding these fields is essential for building accurate models of how the solar system interacts with the galaxy. The role of plasma waves. One of the most significant tools on Voyager is its plasma wave instrument. This instrument measures oscillations in the surrounding plasma. These oscillations are not random. They carry information about density, temperature, and energy flow. By analyzing these waves, scientists can determine the properties of the interstellar medium. They can measure how dense the plasma is, how it changes over time, and how it responds to external influences such as solar activity. In this way, Voyager is not just observing space, it is probing it, a region influenced by the sun. Even beyond the heliopause, the sun's influence is not completely absent. Disturbances from solar activity can travel outward and eventually reach interstellar space. When these disturbances interact with the interstellar medium, they create shock waves. Voyager has detected these events as changes in plasma wave intensity. This shows that the boundary of the solar system is not a strict separation. It is a zone of interaction, where solar and interstellar processes overlap. Building a map. Without images, Voyager is not mapping interstellar space visually. It is building a map through data. Each measurement contributes to a larger understanding of the environment. Over time, these measurements reveal patterns, trends, structures. But this map is incomplete. It is based on a single path through space. And to fully understand the interstellar medium, more missions will be needed. Voyager is the first step, not the final answer. For most of human history, the solar system was our entire frame of reference. Everything we observed existed within it. The sun, the planets, the distant stars beyond. But Voyager has changed that perspective. It has crossed the boundary, and in doing so, it has shown that the solar system is not the whole. It is a region within something larger, a structure within the galaxy, a new scale of understanding. What Voyager found after leaving the solar system is not something dramatic in appearance. There are no new planets, no visible structures, no objects waiting in the darkness. Instead, what it found is something more fundamental, a change in environment, a shift in conditions, a transition from one system to another. This may seem subtle, but it represents a major step in understanding, because it confirms that the solar system is not isolated. It is part of a larger system that extends far beyond it. The beginning of interstellar science Voyager is the first spacecraft to operate in interstellar space, but it will not be the last. Future missions will build on what Voyager has discovered. They will carry more advanced instruments. They will travel farther, and they will provide a more complete picture of the region between stars. What Voyager has done is open the door. It has shown that interstellar space is not beyond reach. It is a place that can be studied directly. The importance of direct measurement. Before Voyager, everything we knew about interstellar space came from observation at a distance. From telescopes, from models, from indirect evidence. Voyager changed that. It provided direct measurement, data collected from within the environment itself. This kind of measurement is essential because it allows scientists to test theories against reality, to refine models, and to improve our understanding of how the galaxy works. A universe that is not empty. Perhaps the most important realization from Voyager's journey is this: space is not empty. Even in the vast regions between stars, there is matter. There is energy. There are fields and forces at work. This changes how we think about the universe. It is not a collection of isolated objects separated by emptiness. It is a connected system, a continuous environment where interactions occur across enormous distances. The future of exploration Voyager will eventually fall silent. Its power supply will run out. Its instruments will shut down, but its journey will continue. It will keep moving through interstellar space for millions of years. And long after it stops transmitting, its data will remain. A record of the first direct exploration beyond the solar system. Future missions will go farther, with better technology, with deeper understanding, and with the knowledge that what lies beyond is not unknown, but measurable. The final realization: what Voyager found after leaving the solar system is not a single answer. It is a new way of seeing, a shift from thinking of space as empty to understanding it as active, structured, and connected. It has shown that the boundary of the solar system is not an end. It is a transition. And beyond that transition lies a region that is still largely unexplored. Somewhere, far beyond the reach of sunlight, Voyager continues its journey, moving through a region that was once only theoretical, still carrying instruments, still transmitting data, still expanding our understanding of the universe. And what it has revealed is simple. The solar system is not the end of anything. It is only the beginning.